So I need everyone to take a moment with me and imagine a place in the world that's about as far away from Aspen, Colorado as you can possibly be. Imagine you're a young Special Forces medic on patrol with your 6-man Green Beret team in the mountains of Afghanistan. You're walking along on patrol when a shot rings out and you hear the cries for medic. You run over to your comrade, assess him as a casualty, and determine that you need to give him intravenous fluids to help him survive. And that's when you're going to start running into your real problems, because the device that you're going to use to save your friend's life has remained essentially unchanged since World War II. And you can see that here. On the left, we have a picture of young Marines in Saipan in 1944 using almost exactly the same IV bag as these Air Force pararescuemen in 2008 in Afghanistan. And what's so striking is that while the IV bags are essentially the same, all of the equipment that the airmen are wearing are some of the most advanced, high-tech, cutting-edge, sophisticated equipment that our nation can provide our soldiers. But that man is still essentially the world's most expensive, highly trained IV pole. And that's a problem that we take very seriously, because not only are we 4 students from the Stanford Business School and Medical School, but 2 of our members are former Operation Iraqi Freedom veterans. And we've seen firsthand how these existing products work and how they're very limited. And we believe that they are inefficient, inaccurate, and provide inadequate pressure. So let's go back and think about that young medic in Afghanistan again. So you've heard the cry for medic, you've run out to your buddy, and you start giving him the IV fluids with this bag. And the first thing you have to do after you stick him with the needle is task another soldier to come out and help you simply hold up the bag so that gravity can feed into the patient. Now, I can tell you as a young platoon leader, I was with the Army's 1st Armored Division, and I did 2 deployments, one to Baghdad and one to Fallujah. And both times, it was incredibly frustrating that with all we would encounter, let's say we were driving down the road, we would hit one of those roadside bombs, an IED, and all the things we would have to do after that. We'd have to deploy soldiers to secure the area, we'd have to recover the vehicle, we'd have to start assessing casualties, we'd have to call to hire, we'd have to call other soldiers in the battle space to come help us, and with all that going on, I would have to pull soldiers out of a critical position to simply go over and hold up an IV bag like Kevin here. And that's just not a good use of people or time. Now, once you've got that bag in and the soldier helping you hold it up, the next thing you're going to have to do is look at this drip chamber and start counting the drops inside it. And that's so you can calculate the rate of flow. Now, that's a lot of time and stress spent working with this bag, counting drops, doing math, and not focusing on your patient. Beyond that, the next step requires you to adjust the rate of flow by playing with this little thumb wheel. I can't tell you how important it is that the medic is focusing all of his attention constantly counting the drops and playing with the wheel and not focusing on the care of his patient. It's just not a good use of time or resources when that medic could be moving on to the next casualty or providing other aid. And even if he manages to get it done all correctly, he's still going to find that this solution is very inaccurate. Now, here's what that means. It means that he's spending all of his time checking the drops, playing with the thumb wheel, and knowing that if there is any change in the height of the bag or the height of the patient, and in particular when you're loading them onto a helicopter or into the Humvee, that it's going to change the pressure within the whole system. And that means going back, recounting drops, and playing with the thumb wheel again. And finally, this solution provides inadequate pressure. Now that means in the event of severe hemorrhaging, when you need to really put fluids into your patient, the ad hoc solution that you as the medic are going to use is yourself squeezing out the bag or putting the weight of the bag underneath the patient. Now, while that's a good ad hoc solution, it means that you're still messing with this bag and trying to manipulate it to suit your needs instead of having a device that actually works for you. And so what I'd like to do now is hand it over to Jake, who will reimagine this young medic situation with the combat IV solution.
Thanks, Seth. My name is Jake Frenz. I was with the United States Marine Corps for 5 years with 3rd Battalion, 5th Marines, which is an infantry battalion. I did 2 combat tours over in Fallujah, Iraq, and what I can tell you is Seth's story is real. These situations exist today with no good solution. And that's why we're so passionate about combat IV, because it's a simple idea and a simple solution, but it solves a problem that has existed since World War II. Combat IV is basically a portable infusion pump. And Kevin is displaying that right now, but we've taken an IV bag and surrounded it with a rigid plastic shell. We have some Velcro straps, but we've attached a dial that allows the medic to set the flow rate in a moment, and also a visual LED screen readout where the medic can see at a glance what the flow rate is or how much fluid has been expended. But at its core, and what allows Combat IV to deliver the fluid independent of gravity, is the elastomeric bag, which is simply a balloon. And that balloon comes preloaded with the IV solution. And when that medic starts the IV line, that balloon squeezes the fluid out through the regulator to create a constant flow into the bloodstream. It's that simple. And that's the beauty of Combat IV, is that it takes a simple solution of a balloon to create this constant pressure to make the bag work independent of gravity. But it has really four main advantages. It works in any position. It doesn't require a medic or a corpsman to hold up that bag to provide the elevation. It works, you can set and monitor the flow in seconds. It is a highly accurate device, and it can deliver high rates of flow when required. So let's go back and let's reimagine the story with Seth and the combat medic in Afghanistan. The medic gets to the scene and realizes that that casualty needs critical IV fluid. So at that point, he takes the Combat IV, sets the IV line, and up to this point, it's the same process as the classic IV solution. But here's where the Combat IV differs, because after he sets the line, all he needs to do is set the dial to the prescribed flow rate, and it's all set. He can then take the Combat IV, strap it to the patient's arm or gurney, anywhere else that's expedient, and go on to the next task, which is often treating other patients or saving critical time. Now, we got more excited when we took our work-alike prototype into the lab, and we started to receive constant pressure flows similar to what you would expect in the emergency room with an infusion pump. You can see the chart there that shows those results. And finally, when the casualty is evacuated to the next echelon of care, the medic can be confident that the fluid is going to be uninterrupted and there's going to be a constant flow no matter what the change in elevation. And this is going to save precious minutes in the golden hour, which is really the benchmark we measure getting a casualty to the next echelon of care. Combat IV is a portable infusion pump for the front line. It solves the three issues that Seth talked about earlier. It's efficient, accurate, and it can deliver high rates of flow when required. And it does this at the same size, weight, and a similar cost to what the current solution is today. Now, we focused on the military aspect because that's where we see the most urgent need right now. But in the development of this product, we've been able to identify many other scenarios where there's an application. Really, anywhere where fluid delivery in the field is required, Combat IV can save lives. And now Matt's going to talk about some of those other situations.
So my name's Matt Tilleard. My background is a bit different. It's in aid work. I've worked in Afghanistan and East Timor, and Haiti and Sierra Leone. Like Seth, I want to take you somewhere that feels a long way from Aspen. I want to take you to Haiti just after the earthquake in early 2010. After the earthquake, much of Port-au-Prince was destroyed, and over 1 million people were displaced into temporary refugee camps. Now, in these camps, diseases like cholera spread rapidly, and they end up killing thousands of people. The key treatment, or one of the key treatments for cholera, is sustained therapy with intravenous fluids and antibiotics. So for a period of 5 or 10 days, everywhere you go, you carry this IV bag with you that's constantly delivering you fluids, because you're losing 8 to 10 liters of fluid a day. So the boy, and this is a 10-year-old Haitian boy, his name's Pierre Wildem, in 2010, he was suffering from cholera, and you can see everywhere he goes, he carries this IV bag with him. When he's receiving, there's a nurse here washing him, and another nurse has to stand nearby, holding this IV bag up in the air. So this is a hassle when it's one patient. This is very inconvenient, but it's not one patient. In a situation like Haiti, it's thousands of people. And each of these people has to hold an IV bag up in the air. So you have hundreds of people out in the sun with family members or volunteers holding IV bags up in the air. Or you have people who have to hold the IV bag up themselves, despite suffering the debilitating symptoms of cholera. Finally, if you're lucky, you're inside a hot tent surrounded by a tangle of IV lines going absolutely everywhere, where IV bags have been duct taped, nailed to any available surface. So we think Combat IV could eventually help change this picture. Device could be shipped, pre-configured for cholera treatment, straight into the disaster zones. Nurses could attach the treatment, set the treatment protocol, and then let the patient go. This could dramatically improve the quality of life for a patient undergoing cholera treatment in these conditions, and also save significant time for medical staff who are stretched completely beyond the limit.
So you've been to the battlefields of Afghanistan, and we've taken you to a refugee camp in Haiti. But our hope is that Combat IV can also change fluid delivery for civilian first responders. We want to take this technology and bring it back home to our local communities, whether it be Palo Alto, where we're from, or Aspen, where we're all currently at. We've spoken to the local paramedics who have echoed the same problems with fluid delivery on their field, from medications that demand accuracy, like the IV and dose-sensitive dopamine for cardiac failure, all the way to the repeated issue of bag elevation and bag placement. Combat IV has a place in many settings. I want to take this time to thank everyone for joining us today. We're a team of students who experienced the need and wanted to find solutions, and it's been an honor to be able to share our story. We are actively looking for champions to bring this product into the military and the humanitarian field and other aspects of first response medicine. And we would love to sit down and chat with anyone else who has experienced this kind of need to share ideas on what kind of things we can do to change things. Our primary goal is to place Combat IV into the hands of that young medic in Afghanistan. Thank you very much.